Am I audible?
No.
Is it audible? Online people?
Yes, beautiful.
Okay. Chalo, let's move on. So if you remember, first day one, I have given the introduction on digital logic, why we need a Verilog, system Verilog, UVM, PSS. Then we got to know that one is a static, one is a dynamic, one language have a methods along with it, ready-made. Okay. Next, if you remember why the automations are needed. So if you want file related automation, Perl and Python are good. If you want automation in a Linux or tool, then shell will be good. In that shell also C shell, K shell, Bourne shell, Corn shell, more. There are different types. If you want anything on internet based automation, CGI script will be good. For graphic GUI, VB will be good. Then you need to learn a protocols. Okay, EPB, HB, XL. Then low speeds you need to learn. Any one will be enough. And high speed, there are many high speed. One among them will be good. PCI is the trending. Okay. Next, tools. Okay, hardly everywhere they will teach only 3 tools. But if you want to survive in the industry, it's better to know all the different tools. Python, Meld, TKDIF, GVMDIF, beyond comparison, Git. Okay. The day then okay, what is Git clone and all you need to learn. Then cron tabs, CTAGs, Jira, Confluence page, Microsoft Streams, Bitbucket. They are the things you need to learn. Then what we do at IP level, subsystem level, SOC level, RTL level, GLS pattern. Everything you need to have in a way. Okay. Then aptitude, resume preparations, puzzles, all the things you need to learn. So it's always good, like you choosing the VLSI, which have a very good scope compared to your IT. Next day, we started with quick review, like what is the course fee, time, placement. Okay. And last batch also, we have done a placement in 25 days itself. Okay. The best record till now is 21 days. A person from Yeshwant from Anandpur district. Next, oh, I think the file not got saved. Okay, last class, if you remember, we started with a digital called number systems. Correct. If you remember, number system we have started. Then in the number system, I have explained in the binary, maybe in octa, in hex, decimal, then hexa. Okay. Binary, why we call binary? Because it have only two values. We call octa because it have 4, 5, 6, 7. Correct. We call decimal because it have 10 value. Then hexa because it have 16 value. F. Correct. So they are the different number systems which we have studied. Then normally, as you know that in every wave, there will be one conversion will be there, correct? What normally convert digital to, okay, sure. So first topic will be like number system, which we have studied. Then in that, what are the different number systems we have? Then conversion. I think you have done the same in the college days also. Digital, sorry, decimal conversion. Okay, example, decimal to binary, decimal to octa, hexa. If you remember, we have took one value. Okay, can anyone repeat what is the value we took? 98.25 we have done. Okay. So only one example I'll teach that remaining you can get to know. What was the equivalent we got? 110010, correct? Dot 01 in binary, correct? Triple, correct? Next, 98.25 of 10 dash 142 point 142 point 142.2 in this one. This next 98.25 of 10 is what? 62.4 in hex. This we have done. Next, we started with binary, right? Binary conversion. Okay. Binary to octa, binary to hexa, binary to decimal. Okay, sorry, decimal hexa. Tell me here. Double 1 0 0 1 0.01, correct? Is equal to what? 142.2, correct? We got them. I have explained you the method also, correct? Next, 1 1 1 0 dot this one equal to in decimal means what? 98.25. Next, 110010 is equal to what? 62.4. Next, I think we done with only two. I have explained you all this one. Okay, shortcuts and all we have done. Now next our agenda will be like octa conversion. Octa to binary, octa to decimal, octa to hex. Correct. Okay, I'll give a minute time. You tell me how will you do it, all the three approaches. Up to you already done in engineering, right? Octa to binary. Correct. Convert each digit separately. 142.2 of 8 equal to what you will do? Convert each digit separately. So what is the equivalent of 1? Next 100. Next 010. Next 0.010. Correct. Is it equivalent to whatever we have seen above? Is it the same this? First of all, this is equivalent to this. Both are same. They both are same. They are equivalent to this. So done. Okay. Chalo. Next. Octa to hexa. But decimal I'll come later. Correct. What you said. Tell loudly. Correct. Octa to binary, binary to hexa. You know. So can I write like this? I'll make it equivalent to 0 0 1 1 0 0 0 1. Correct. Sorry. I have written ulta. 0 1 0 0. Next 0 1 0 0. Correct. 0 double 1 0 double 1. Correct. Next 0 1 0. Back we can put 0, right? One extra if you need. This here. Front only, right? Here we can put extra 0 if you want. What is the equivalent? Correct. Oh, sorry. Actually, what we had 0 1, right?
0 1 0 0.
0 1 0 0. Okay, correct. Sorry. Clear? Did we got what we needed? Okay. Octa to decimal. Octa to decimal. Eight power 2 plus 4 into 8 power 1 plus, next, what is the value? 2, 8 power 0 plus 2, 8 power minus 1. Okay. What is the 8 power 2? What is the 8 power 2? What is the into 1? Okay, next. What is the 8 power 1? Plus into 4 plus 8 power 0, 1 into 2. Okay. Plus 2 sorry, here. 8 power minus 1. See, can I write 2 by 8? Can I write as 2 by 8? 2 by 8 means 0.25. Can I add and tell me what will be the value? 98.25. Correct? All the things I'll repeat it. No, do not worry. Okay, one more time. Done? Okay, next hex conversion. Hex to binary. Hex to decimal. Hex to oct. Hex to decimal. One 42.2. What shall I do? How many values? 4. 1 minute. Did we make it? Did we? Correct? Then dot 0, 0, 1, 0. Correct? Is equal to. Can I write like 1, 1, 8? Extra to binary. No, we got wrong, no? 001, 0100, 0010. What I made a mistake? What is the mistake I did? Tell me. What I need to do? Actually, I used 142. 142 is equivalent to what? Octa. Obviously, you will get a different value, right? What I need to use? What is the value I need to use here? 62 point? Sorry, 62. Question itself is wrong, then obviously answer you cannot expect, right? Tell me. Split into four digits. Did we got what we needed? 11000010.01. That is what you needed. Did we got of? Now next 62.4 of 16 equal to what? How to do it? Huh? Pardon? Hexa 2? Instead of that, any other plan? What to do? Hexa 2 binary. Then now we have above number above already we did, right? 3 3 okay. 001 100. Is it correct what I have written? Now tell me. Correct? Huh? Next, how to do it? How to do? How to convert to decimal? No. Correct. Number into 6 into 16 to the power of 2. Sorry, 1 plus 2 into 16 to the power of 0 plus 4 into 16 to the power of 10. 16 6 plus 16 put to the power of 1 is 1 16 into 6 96 16 to the power of 0 1 into 2 okay plus 4 by 16 can I write like that? That is that number 4 by 16. 4 by 16 is nothing but 125. That entire I can write like what? Yeah. Anyone have any doubt? Now tell me anything, any other number system do we have apart from the like conversion normally for conversions? Anything else you did in your engineering? So, huh? No, BCD is different. BCD is there, X3 is there. Okay, that is a different topic. We'll go signed, unsigned. That all I will go to different. Here, conversion. Normally in the conversion, what you have learned? Only this much. Okay. Now quickly I'll go give the overview of all the things. Then we will move on. So decimal to binary, how you did? Multiplication by? So division by? What are the number what you had it? Another number you had it. This number you did what? Sorry, division, correct?
Yes.
Division by 2, 4, sorry, 2, 8 or and this number what you did? Huh?
Multiply.
Multiply by what? 2.
2.
Clear? Anything else we need to learn in a decimal? Then all the three topics we covered. Okay, so next. Binary conversions. Okay, how you did? Binary to octa. Huh? Split. Split the binary value into character. Three digit you need to split, then you can convert. Then convert to octa. Then here. See, I hope you people know this, but I don't have to tell. A 3 means you don't have to take like this. Will you take like this? From decimal point only you need to see, correct? So I hope you don't need this explanation. Correct? Splitting will happen 3. Okay. Split the binary value from decimal point. Correct? From the decimal point. Left side and both. Correct? So split like this and convert. Next, binary to decimal. How you did? Power. Multiply each binary value by power of 2. Correct? Multiply each binary value by power of 2. Do you remember? Next. Split the binary. Value from point into 4 digit. Then convert to hex. Clear? Chalo, done. Next. Octa. How you did the conversion? Write each value in terms of binary. Right. Each one. Correct? Next, what about this? Multiply each value with by power of multiply each value by power of. See, what do you mean by power of 8 means? 8 power 0, 8 power 1, 8 power 2. I hope you know this one. Power of 8 means. Octa to hexa. Correct. Octa to binary to correct? Octa to binary to hex. Next, how you did hexa to binary? Number into multiplied by 16. Number into no, what hexa to binary? Direct equivalent.
4 bits. With
4. Okay, right? Right? Each value in terms of 3-bit binary. Here,
4 bit.
correct? Hexa to octa. How you did? Hexa to octa.
Convert it into binary and then 3 bits.
Hexa to binary into octa, correct?
Yes.
Hexa to decimal. Multiply each value by
16 power.
Here. We get all our self-explanatory here. Anyone have any doubts? Online people? Anyone want me to explain anything?
Sir,
Hmm?
sir, just explain the X to octa, how X convert into binary and then octa. Please explain it.
Here, extra to octa, this you are talking.
Yeah.
Nothing. See, 62 is there, right? 62
Yeah.
can I write like this?
Yeah.
The same, this value only I have written here. You can see in terms of 4, okay. From here, from here.
Okay.
1, 3, 3. Now, hexa to binary done. Hexa to binary done. 3 hexa to binary. Can you see here? Do you agree?
Yeah.
Now, binary to octa. You know binary to octa.
Hmm.
What is the 001 means? 001,
Zero.
100,
Yeah.
010, and 010. Clear?
Yeah.
What?
Okay. Okay, sir.
Done?
Yes, sir.
Give a minute time, make sure complete. Okay, one small question I have. You have seen watch ad? No, normally watch ads mean either clock or watch, whatever it is. Any watch, when you see, what is the, in the ad, what is the time they mention always? 10:10. 10:10. Let's see here. Is it 12? 10:10 only, normally, any watch you take. Why? How will you draw the smiley face? Right? Your smile. What is your smile symbol? 10:10. 10:10 is your smiley symbol. Okay. And there is a time when one of the important US president died. Normally, 10:10 indicates your smiley face. Smile, how will you write? Like this one, no? What is that equivalent? Yeah? I think everyone are aware like what's going in UP Canada. Mahakumbh, right? Mahakumbh, have you heard? How many people are expected to come there? How many crores? 40 crores. 40 crores. 40 crores will be going to come in within 40 days. That is what the estimation. Okay. In one single day, okay, January 15 or 40 Makar Sankranti. 3.5 crore people came on one single day. Okay. Why like we called Mahakumbh? Every 6 years, actually the Kumbh Mela will happen in 6 years. That is called Ardha Kumbh. Okay. If it happens in 12 years, we will call it Purna Kumbh. And 12 Kumbh, 12 Purna Kumbh need to happen. 12 Purna Kumbh means how many years that will take? 144 years. That is called a what? Mahakumbh. 12 Purna Kumbh need to happen. Okay, where all the this Kumbh Mela will happen? Only Prayagraj. 4 places: Haridwar, Nashik, Ujjain, Prayagraj. Okay, this Kumbh Mela will be giving a scoot up to the GDP of our India. Almost by 0.5 to 1% GDP will improve. Okay, so you major like a tourism sector will improve. Then anyone have it? Can I rub
Sir,
this?
why we need this number system and which is the best number system that we
Correct.
have used?
Yeah, they give one question. Like I'll answer this question once I have so many other number systems. X3, binary and all. Sorry, BCD. Correct. Grade 2. Okay. Once I complete this, all the number systems, then I'll give you like why we need this many number systems. One is enough, right?
Yes, sir.
Now, if all that, let me move on. Okay. See, you are not supposed to during your exam time. Don't learn. They just for your understanding. They what I want you to learn. Now, what I'll be putting. Number system means only the table you need to know. That's it. It is more than enough if you go through this table. That is enough for you. I'll just do this way. Decimal, binary, oct, and hex. Decimal, binary, octa, and hexa. Decimal to decimal, can you convert? Binary to binary. How will you convert octa to octa? How will you convert hexa to hexa? No, you don't know. Okay, then leave it. Next, decimal to binary, how will you convert?
Divide by 2.
Whatever your number will be the example. Divide by what? 2. And clear?
Correct.
You know what to do next, correct? You can follow. Next, 98.25 divided by
8.
then here. Next,
Divide by 16.
do I need to write anything? They are self-explanatory. Hello, next, binary to decimal. Binary to decimal, how will you did? Like, can I write like this? X into 2 plus x into 2 power 1 plus x into 2 power 0 plus x
Yes,
into
sir.
power minus 1 like this. Can I write like this? Where x is your binary equivalent. X is binary equivalent. Octa to decimal. Binary to decimal. That whatever the value will be there, x is your value. X is which value? Binary value, right? Now, octa to decimal, how you did it? Tell me. Huh? X into x into x into x into correct? X is what?
Octal number.
Octa value. Hexa.
X into 16 power 2 plus x into 16 power 1.
You put a extra this and dot. So it's a self-explanatory, you need to do it. X into 16 power 0 plus x into 16 power minus 1. Correct? Where x is what?
Hexadecimal value.
Hexa value, correct? So what is the
Yes,
learning?
sir.
binary, octa, hexa, anyone to decimal. Their equivalent powers you need to do it. See, can I make one conclusion? Decimal to anyone. Decimal to anyone. How will you do it? Divide by 2, 8 respective radix. Divide by respective radix and multiply decimal by the radix. Decimal to anyone. Anyone to decimal. You got what I mean? Decimal to anyone means binary of
Multiply with
fraction.
based.
Divide by 2, 8, 16 radix or multiply by 2, 8, 16. Anyone, this is what? Anyone to decimal. Anyone to decimal means what? X power 2, like a power of 2 or 8 or 16. Okay. The divide and multiply rule. The what? Power rule. What do you call? Power. Correct. Divide by 2 you did. Here what you are doing? Power by? Divide by 8 and multiply by 8. Here? Power by? Here divide by 16, multiply by 16. What you did here? Power by? Here. They follow power rules. Okay. So what shall I write here? Divide by 2, multiply by 2. Okay, see, divide and multiply, we have generalized. What shall I generalize here? Power of? Power of radix. 2, 8 or 16. Is it clear? Can I generalize this part? Chalo, next. Binary to octa. Binary to octa. Group of
3 bits.
3 bits. 3 bits. And write equivalent, correct? Oct equivalent. Do you agree? 3 bits you need. If you, group of 3 bits you will do, and you need to convert to what again? Octa equivalent. Correct. Next. Here what? Binary to hexa. Group of
4 bits.
4 bits. And hex equivalent. Done. Next. Octa to binary.
నీళ్ళు కాంచవా నీళ్ళు పోసి పెట్టు ఫస్ట్ పైన నీళ్ళు లేవు తాగి
Okay. Octa to binary.
Divide by 8.
Hmm.
Take a remainder.
See, that is a group. This is split. Binary value of that you are grouping into 3 and converting. Here what? Each value again you need to split. Split into what?
3 bits.
Into 3 bits. Do you agree? Split. Of 1 minute. There I will make one correction here. Split each value, each octa value into 3 bits binary. Correct? 3 binary bits or 3 bits binary. Next. Hexa to binary. Hexa to binary. Split each hex value into 4 bits binary Correct. Next. Next, octa to hex. Huh? Huh? What are your x will be there in terms of 8 actually that you will do into x power 2 into 16, correct? What do you mean? Value to need to be converted to what? To
Minus
x. Tell me here. Your value will be there. 16 bit. You need to convert to what?
binary
Then what you need to convert to what?
octa.
Correct. So totally number systems if you are asking, can I categorize them into one zone? Can I categorize it into another set of rules? Can I categorize them into another set of rules? Can I categorize into one set of rules? Can I categorize them into another set of rules? Continue many times, complete this. See, if you know this table 100%, you don't have to learn anything. They are more than enough to convert any number system. Okay, this will be how your entire digital you will be learning. Just explanation, then table you need to remember. Done? Done? Okay. So quickly we'll revert. Decimal to anyone you want to convert, what you will do? Decimal to anyone. Divide and multiply. Anyone to decimal means power of radix. Binary to octa or hexa means group of 3 and 4.
4.
Octa or hexa to binary means 3 and 4. Octa to hexa or hexa to octa means indirect method. What is indirect method?
First
Convert
convert it
to
into binary.
binary, then to octa or hexa. Clear? So totally, how many rules we need to remember? 5 rules. If you know 5, any conversions you can do it. See, I'll just summarize all this in one small. This one. Hope you're gonna help me. Decimal to anyone. What is the rule? Divide by correct. Divide and multiply by given radix. Anyone to decimal means power of the radix.
Radix.
Clear? Now
Yes.
binary to octa or hexa. Group of 3 bits for octa and for
4.
clear. Octa or hexa to binary means split into 3 bits for octa and 4 bits for hexa. Octa to hexa or hexa to octa. If it is octa to hexa, what you will do? 8 will convert to 2 to the 16. Clear? Or hex to octa means we'll take hexa, convert to 2 binary to the octa. Clear? Is it clear? Okay, all the explanations are given. Done. Decimal to octa, how will you convert? Divided by 8. Octa to hexa.
Yes, sir. Convert it into binary and then group of 4.
Okay. Binary to decimal. Power of
Multiply power
No.
of radix
power of radix.
10.
Octa to binary.
Group of 3 bits, sir.
Split, not group. Octa to binary.
Sorry, yes, sir.
Binary to hexa. Group of 4.
Split of 4 bits.
Okay. Just do not remember anything. Just remember the note, I think. Now I have given all the explanation. The note is more than enough for it. Okay. Only 5 rules. Decimal to anyone to decimal, binary to octa or hexa, octa or hexa to binary, octa to hexa, hexa to octa. Okay. One rule is decimal, divide and multiply. One rule. Another rule is power of. Third rule is group or split. One is a grouping, one is what? Splitting. Okay. Two more rules done. And one is what? Indirect method. Convert to binary and then to the respective. So what, like once again let us revise. Divide and multiply, one rule. Power, another rule. Group, another rule. Split, another rule. Then indirect method. Okay, convert to binary, then to the oct or hexa. Clear? So 4 rules. What are the 4 rules? Divide and multiply. Second rule, power of radix. Next, third rule, group or 3, group of 3 or 4. Next, split of 3 or 4. Next, indirect method like what? Octa to binary to hex, hex to binary to oct. Okay, clear? So last time, close your book and tell me anyone to decimal. If I want to convert anyone to decimal, power of radix.
Radix.
Okay. Binary to octa or hexa.
Group of 3 and group of 4.
Group of 3 and group of 4. Octa or hexa to binary. Split of 3 and 4.
4.
Decimal to anyone. Divide and multiply.
Multiply. Yes.
Okay. Octa to hexa or hexa to octa.
Convert it into binary and then
To
group it.
octa or hexa respectively. Clear? All the rules are clear. Can we move on? So if
Yes,
this
sir.
clear, let us move to the see this completes your number system. No. Now, can you tell me if it is a decimal, if it is a binary, if it is a octa, if it is a hexadecimal, okay. If it's a BCD, how will you write? If it's a XS3, do you remember we had one more XS3? Gray code. Correct? Did we had this one? Okay. See, we call a weighted number system. What do we call? And what do we call this? Non-weighted number system. Clear? Now, decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How to write it? We'll see in equivalent of all the 3 people. Binary, how will you write?
0001.
10 11 100. Next. Next. Next.
111.
Next. 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 Done. Correct. Octa. Can you tell me octa? Next. Next.
Again 1.
Next. 10. Next. 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 If it is next, then 20. Hex. Ten. Next.
B.
Next.
E.
Next. Suppose if I want to write 10. Next. BCD. Huh? How will you do? Four digits. Tell me how. Next. 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 10.
1.
10. Is it correct? Okay. Google 10. You check and tell me. I'll stop it here only. Next. From
Correct
here.
September.
Huh?
Correct September.
Correct.
1010.
Hmm.
Yes,
Next.
yes.
Okay. X is 3. One it will be 1 it will be. To whom you need to add? Actually, X is 3 means what? BCD plus 3. Okay. So tell me now. Next value will be what? Next. Sorry. Next. Next. Next.
100.
Next.
1001. 1010.
1010. Next. 1011. Correct? Very good. Next. Next. Whatever the binary you got, we should like 3 will be keep adding. Gray coding. Gray. Decimal 1 gray code. Decimal 2 gray code. Okay, gray code, what is the rule?
When did it should change?
Tell me. You have done, right? Gray code. Okay, tell me. You want to correct the chip of the Qualcomm? See, you are preparing your
XR operation to be done between binary bits.
okay. Each binary bit shall we do the XOR?
First
Yes.
bit as it is, sir.
First IGT, then
And
two.
Then XORing with
XR between the bits.
Okay, we'll do one thing. I'll write a Karnaugh map. Then that map we will take it and we'll check if it matches with our requirement or not. Okay. Even I need to give it a try. Okay. Like that. I'm not sure whether it will work or not, but still okay. I got some idea like can we remember like this? Just give it a try. Even I don't know whether it will be correct or not. We write like this, 0, 1, 2, 3, next 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15. Correct. Now, K map, can you tell me the K map? 0, 1, 2, 3,
3,
5.
4, 5, 7, 6,
Okay, then 8
4,
here, 9, 11. Next. Correct?
yes, sir.
Now, can anyone ask the chat GPT and get this details are correct or not? Take double check and tell me. Decimal and gray coding. Decimal and gray code. Okay, let me just ask it to generate or leave it. We'll ask the gray codes. Even I'm not sure whether it will be match or not.
Correct, sir.
Huh?
Correct, sir.
Correct? Huh?
Yes, sir.
Binary to gray code. is 0, 1, next 3, next 2, next 4 is equivalent to 6. Did I made any mistake or how? 0, 1, 3, 2, correct? 6, 7, 5, 4, 6, 7. Got it. Clear. This is correct only. Correct. You are, if you read like this, it will go wrong for you. Sorry. Your reading need to go like this probably. Like this. Like this. Like this. Like this. Now check. 0, 1, 3, 2, correct? 0, 1, 3, 2. Next. 6, 7. 4. Next. 12, 13, 15, 14, 10, 11. You can check. 1. Huh. 0, 1, 3, 2, correct? 6, 7, 5, 4. Next. 12, 13, 15, 14. Next. 10, 11, 9. Correct. Show you. Now, give me 1 minute. How will you remember this? Your decimal. Your reading will go like this. Gray. Snake. First of all, table wise, we got it very clearly, like how quickly without oral, you have one option like take first bit, written as it is, then the XOR operation you need to do, right? To get it. Oral, simple table is there. From the table you can get to know. I'll give you a minute time. Okay, do I need to convert or can anyone tell me here? Gray code, tell me. First value will be what? Actually, I have not written one value. Correct now? 0, 0, 0, 0. Okay, better like. Correct. Now tell me here, gray code. 0, 0, 0, 0. Okay, sure. Next, 1 minute. Next, 0, 0, 1. Next, 0, 0, 1. Next, 0, 0,
1 0
next,
0 1 1 0
next, next,
0 1 0
next,
0 1 0 0
next,
1 1 0 0
next,
1 1 0 1
next,
1 1 1
next,
1 1 0
double 1, 1 0.
Yeah.
Next,
1 0 1 0
next
1
1, 1 0, 1. Next, 1 0, 1 1. Next,
1 0 0 1
1 0 0 1. Next,
1 0 0
8, correct? Did we did any XOR operation? Not yet. So keep in mind your numbering, you will write like the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These arrows you need to follow. Gray to gray code you need to convert means the K maps. So utilize that, no? K maps is developed on what? Gray code only. That basic rule, right? K maps is developed on what? Gray coding only. Then write your K maps. Okay, from there you can get the numbering. You don't even have to remember this. Like if you know this one, easily write 0, 1, 2, 3, 4, 5, 6, 7. In the bottom 8, 9, 10, 11, 12, 13, 14, 15, and write in a snake format. You can make a note of this. See, left will be correct. Whatever you said is correct. 0 unit, first bit you need to remain as it is. Then 2 bit you need to do XORing. So which one is easy to remember? Shall we remember the numbering or shall we remember the K map? K map and snake. Done. Okay, can we? Number system, again, if you want, we can classify them into 2 types. Weighted number system and non-weighted. See, now weighted means like, first of all, here, if you take a binary, octa or hexa, the moment you vary the positioning, each position have its own value, correct? But if you take into the extra, will the position have the value? See here how to tell means. Here 0, 0, 1. Example, if you take this binary, zeroth position have one value, first position have another value, second, third, correct? On the basis of each position have one weightage, correct? Now here on the gray or x3, do you think like that? No, we don't have that. They have one bit difference from consecutive values. One is a weighted number system and one is a non-weighted number system. Here you already have seen binary, octa, hex, BCD. Here x3. Next, gray coding. Gray coding also will come in this one. x3 always is equal to whatever the BCD numbers will be there, plus 3 you add it. That is how you will get this one. Next, gray coding. Gray coding, how will you get? Using a one K-map is one rule. Okay, another rule is what? Okay, do one thing, write one K-map. Okay, sorry. What are the, for this one? Okay. For 2, you need to get 3. How will you write it? 2 means get its this one. How will you do to get a gray coding? How will you do the gray coding actually? Tell me the gray coding. See, if you remember, how you have done in your college days, recollect yourself. Your teacher has said, this bit you need to retain as it is. Okay, I retained as it is. Then what your teacher said? These 2 bit, what you need to do?
XOR operation.
0, 0, XOR is what?
0.
Next, what your teacher has said?
0 XOR with 1. 1.
1. Next,
1.
so what is that equivalent? 2 equivalent is what? 3 only, right?
3.
Okay, one more value we will take. Any value. 1, 1, 0, 0. Shall we take? Can you get 12? As per our table, what do we need to get? Can anyone tell me? As per our table, what is the value? 12. Decimal is what? Gray. What is 1, 0? 1, 0, 1, 0 is the what expected? Tell me. What shall I write first?
1. 1.
Second,
0.
third,
1.
fourth.
0.
What is in our table? 1, 0, 1, 0. What we got?
Same.
How actually you convert to gray? The value you need to take. First bit need to MHB need to be as it is, and third and second and 1 and 0. Okay. So this bit you need to be as it is, right? And this bit is equivalent to what? XOR of this 2. These 2 bit will be. This bit will be what? XOR of this. Next, these 2 XOR if you do, you get this. Okay. B3, B2, B1, B0 is equal to what? B3, B3, B2, is it correct? One example you write it, and this you write it like how to do it. Actually, we call G3, G2, G1, G0, correct? No? G3 equal to G1, B3. Gray third digit is equal to binary third digit. Gray second digit is equal to XOR of binary third and second. Gray first digit will be equal to binary second XOR binary 1. Gray zeroth digit is equal to what? Correct?
Sir,
Huh?
sir, I have one doubt in number system, sir.
Huh?
Sir, you had explained the standard radix like decimal, binary, octal, and hexadecimal.
Hmm.
What if in a case they have given to convert radix 5 to decimal, radix 6
No, we
to
don't have.
octal?
First of all, this kind of radix only not there.
No. Sir?
No, see now, okay. Well, let us tell like this. So binary, okay, you heard. Okay.
Yes, sir.
Any,
Hmm.
I mean, of 2, correct. Anything
Yes,
of
sir.
radix 4, have you heard?
No, sir.
Radix 5,
No,
radix
sir.
7,
Hmm.
8 we
Hmm.
have heard. I get octa. 9,
Yes, sir.
no. 10,
No.
okay, we heard I get
Yes,
decimal.
sir. Decimal.
So whatever the radix you said that is not even available. Okay. Now the question, why not available? See, even example, you may have a question with why the octa they have introduced, why hexa they have introduced. Correct.
What that?
So,
Yes, sir.
so next class I'll be telling you all the number system importance.
Okay, sir.
That time we'll get to know that this kind of question you'll get an answer. Why then radix 4? That is, we don't even need anyway. Okay.
Okay, sir. Thank you, sir.
Just thinking on the same line, shouldn't we be doing for 32 and 64 repeated? Won't that make it make easy, like higher now for system architecture or something?
Mean you are telling like hexadecimal, we have written a A, B, C, D, E, F. For 32-bit also shall we write like A, B, C, D, E, F, G.
Something more convenient. thinking of like something advanced like system architecture or
No, it will even a complexity will happen. See, binary means what we will play with the two bits, which will be very easy for us. Okay. Now, if you come with another coding systems, that's still a hectic for us. Done. Okay. So we have a concern like why the number system. Actually, I need to study. Okay. So one example I'll tell you. By this number system, okay, let us talk about a gray coding. Where it makes a difference in your life, gray coding. Man, don't small laugh, man. You are telling like I will develop the Intel chip, Qualcomm chip. You said like I'll become I'll solve the complex VLSI circuits. Finally, you don't know the digital only. Okay. Tell me.
In memory orientation, they use.
See, one simple I just tell now only,
Sir,
right?
pointer. We can use it in a pointer, sir.
No, here I said like a gray coding. Where you use the gray coding?
K-map.
K-map is very for to solve all the Boolean expression. You need a K-map.
Yes,
All
sir.
correct. So there with the help of K-map got introduced. Back end of the K-map backbone is what?
gray code.
Gray coding only, right?
Yes, sir.
Okay. So we have some more things to be discussed in the number system. What is signed? What is unsigned? Okay. So then comes complementary. One's complement, two's complement, seventh complement, eight complements, nine complements, 10 complements, 15 complements, 16 complements. We cannot remember all. We need one shortcut. Okay, with one shortcut, we'll close everyone. Okay. So in next 4 minutes, I cannot start anything. So we'll just stop it for the day. Okay. And today I have some work, so I may not be able to take any class today. So we'll be winding up for the day. Okay. We'll continue on the Monday again. Okay.
Then when we'll start the test cases, so we
Yeah.
plan.
And next class, next Saturday or sometime I'll take it, and only I need to explain the regression part and all. Correct. I'll take one day and I'll complete that part.
Please explain as soon as possible, sir, because interview the main question is test cases. So that's why.
Nothing. She very simple. I'll just tell you here only. Okay. Just you just wait. Just I'll take 5 minutes. Now I'll just give you hint. Okay, here.
Any document do we have for this,
Which one?
for the test cases?
No, test case like you don't have like document. You need to write the code only here. Just 1 minute.
It's to be written in Excel or how it will be?
Huh?
To be written in Excel or
No, this is coding. Okay, test case. Now, actually, see here. I'll just give you a hint for you how to do it. See, the one sequence you have written. Okay. Here, you write it one more sequence. Let us call APB write a sequence. Okay. Now, randomize you are doing, right? Randomize when you do, it will randomize everything, all the values. When you tell write operation, P write value need to be what? Can be 0 or 1 or any fixed value. So what? P write value need to be what? P write value need to be 1. So tell him line number 66. You know inline constraint with.
Yes, yes, sir.
Do you remember? So
Yes, sir.
randomize this by keeping a P right equal to what? 1. That will give you what kind of sequence? Right sequence. Okay, just 1 minute. I'll take another this one and I'll make it RD here. Okay. Now, instead of randomizing everything, What I'll randomize all the signals, but I'll keep P right equal to what? No. 1 if you keep what operation? Now what operation you want to do? Only read. So what you will do? 0. You need to do with 0. Next. If I mix the above two statement, okay, this procedure followed with now if I write like this, what happen? Here P right equal to 1, I'll do it. Here P right equal to 0, I will do. So what operation it will happen? Right, read, right, read, right, read, right, read 5 times. Do you agree? So just one line changes, nothing else. Almost all have we repeated the same, only one line you need to change. So you created a different 4 types of sequence you created. One is a randomized sequence, one is a write sequence, one is a read sequence, one is a write read sequence. 4 sequences you created. Now what you need to do? Those sequence you need to pass in a text. See, I'm just giving you an overview. Okay. So now here you are telling APB sequence. Next time here, don't tell APB sequence. What you need to tell? Correct. See, this is you can write APB text. One more, you write one more text that called like APB write text. Where only changes you need to do here, 5th line and 14th line. Next time, one more text you need to write with a read text. And you need to change the sequence name. One more text you write, APB write read text. Change here and here. That's it. So 4 sequences you create, and according to that 4 text you create. Yeah. Now those text here, what you have written APB text. Instead of APB text, if I write here APB write text, what will happen? Write text will run. Read text will read text. Write read will write read text. So like the 4 text you can make it different. Okay. I just given a glimpse. Okay. It do not need much time. Next class, okay, any day, or else we can do one thing. Someday, like we can take, we can wind up the class by 7:30 digital, and half an hour if we take, this will complete for you.
UVM callback method, for example, in driver code,
No,
the test cases is corrupted. What kind of error injected? These type of questions they are asking, sir. And also, if you are not any right test cases, how to implement take to automatically?
No, I
This,
didn't. What this? What next? What was that?
if you are not if you are not write any test cases,
if you not write any text case, yeah, okay.
how to take the test cases automatically?
No, 100% not possible. You need to write a text case. Correct. Without writing a text case, how you can do it automatically? I don't know
I
anything.
don't know, sir, actually.
No, I don't know anything like that. Okay. You need to
And also in driver code, test cases is corrupted. How to inject the error?
no, like your question only have to think. Already corrupted means already it have a
Error inject test case.
no. See, for corrected thing you will inject an error. For wrong text, wrong thing you will not inject error. See, your question like need to be like this. How will you do the error injection? That have a meaning. Okay. For corrupted, you will not proper one will do the error injection. Error injection because to check if I give an error, still it need to work properly. Okay. That we can take it in AXI part. Okay. Next, error injection one part. Next, regression I'll complete by the only few sequence I need to create few text. Okay, it hardly
For
takes.
example, test case, test controller, PVT, all are same test cases, sir. These read,
No,
write.
no. You go through the video, you'll get to know that all the functionality are different. No, they are not same. They are all different.
Data flow test cases, you mentioned that the error test
See,
cases,
no
negative
data.
test cases, connectivity test cases, you told like that theoretically. But
Yes.
how to write all these things
See,
in
one
practice?
that one if you need SOC video is there, PVT HFR. In that time during the SOC, because connectivity will not come in your IP things. The APB is one single IP. In IP you will not have anything called connectivity. When you come to the SOC verification, then only you will have connectivity. Okay, so that
I saw all the videos, sir, but you told like that only the connectivity test cases, negative test cases, data flow test cases. How to write in practically these things, test cases?
see, one thing. Okay, I'll just give you the glimpse. But connectivity, they are all SOC based test cases. See, SOC based test cases will not be like as it is like UVM. Company to company differ again. You need to see their architecture. According to that architecture only you need to modify.
If they are asking
First
write
of
a
all,
test cases
no,
regarding
100% they cannot ask this one because SOC based verification test cases, company to company it will differ. It's not like UVM, you will have the same IP will be uniform. But company to company, one thing I'll tell you, I worked in SanDisk. That architecture, how the setups are there, they are not the same way in AMD. Okay. Do one thing. Okay, next time if any student comes now from different company, I'll show their laptop and I'll show my laptop. Okay, you'll get to know. They never be the same. So you do not have one flow at all. Generics, what we need to do, that we can teach. In general, how to do it. Okay. So that all SOC related will be covered in the later stage. Okay. Because like the only on a IP side I have targeted. So APB one single IP, right? So here I'll be explaining here. Whatever the connectivity or maybe error injections, they are all needed on the your SOC side. So when I teach the SOC project, during that time I'll teach or 100% in the video when I said this word, I have given an each line explanation. But coding wise, 100% keep in mind, coding wise, you will not find here nor in any institute. SOC based verification you want me to do means I need to buy one processor. Okay. Just do one thing after this meeting, go to ARM website, ARM website. I said last time also, if you remember, there are 3 types of processor comes A, Cortex R, Cortex M. Any kind of Cortex A series or R series or M series. Okay. You just get me the price of that one. Because even any company, service company also will not be having a processor. They are all very costly. Okay, so that 100% we cannot do practically here. Okay, so what they will do, I can tell only on a theoretical part, SOC based verification. Okay, so on theory only, what error injection test means, what they will do, that kind of thing. Error I can tell. Connectivity means what happened. There will be one source, there will be one destination. So source to destination. See, if you watch that video, 100% I have said. Source and destination will be 2 points. Source will give 1, then destination you need to get 1. If you give 0, you need to get 0 on the other side. Okay. So this one cannot be taught. Okay, but only theoretical part I can explain. Okay, and that too when we come to the SOC things. Okay, if you have anything, but I can take you like a next class, 5 minutes or 10 minutes. I can give you the glimpse. Okay.
when we will use UVM callbacks, sir. When we will use UVM callbacks.
See, callbacks simple. It's a callback means what happened. You will call another thing, one function, and internally if it calls another, that is what callbacks we call. Okay. Now this callbacks, if you need, this one we will be doing later in the session. RAL one more in the UVM. There is one more topic I left. If you remember, RAL topic. Do you remember? UVM RAL, I have not explained.
Yes.
During when I teach that, no, that will come, that topic will come. Okay, so whatever I have explained in the UVM, that is equivalent of your SV, correct? Do you agree? When I was explaining the UVM, whatever SV equivalent with that only I have explained. But there is some advanced concept in UVM which I have not been covered, that we will be covering later. Okay, example RAL. Do you have an equivalent in SV? No, we don't have it. That again different topics. Okay. So UVM pool, UVM RAL, UVM callbacks, they are all advanced topics. Okay, that we will keep it in the last. Okay. But regression, 100% whatever you ask, regression we will be covering test case, test plan, regression, test, different sequence. That will come here only. So I'll cover in the next class. Okay.
Sir, can we have one session where we discuss interview questions? I think even I have a lot of questions to ask.
Okay, do one thing, no. Then every day, if you people have any like question to be discussed in the when the class starts, no, just drop one message in the chat only. Sure, we'll discuss the questions. So every day, 10 minutes will wind up early only, no. So 10 minutes every day, 1 or 2 question if I discuss, because whatever the question is, you know, I want to discuss with everyone, because along with you, it will helpful for other people also. Instead of on call, because on the call you will also not get clarity, correct? So every day you can keep 1 or 2 questions, we'll discuss it. Okay. So any day, keep in mind, if you have any kind of a doubt, you know, just drop a message. Just close the class by 7:50 today. So I'll understand like you have a question. Okay. So we'll wind up and your question will helpful for other people also.
Okay, sir, sure.
Huh?
So we can follow this.
You just always drop one message on the chat. So we'll wind up early. 5-10 minutes, we will take the discussion. Okay. Okay, then we will wind up for the day. Okay, I have some work, so I may not able to take the class today. And again, we'll be seeing on Monday. No class for the day. Okay. That's